Welcome to qnawire.
Hi, so over here, a chemistry student is given 450 milliliters of a 1.3 molar trimethylamine solution, and this is going to be a weak base with the corresponding value. What mass of the associated conjugate acid or the weak acid that we're going to have should the student dissolve in the solution to turn it into a buffer with pH equal 111.02? So over here we may assume that the volume of the solution doesn't change, so we only need to consider the amount of mole that we need to add into the solution. In order to do so, we're going to employ, as you were asking, the Henderson-Hasselbalch equation. In order to employ it, first of all, we need to know the value for Ka. So what we can do directly is remembering that Ka times Kb is going to be equal to Kw. This tells us directly that the value for Ka would be equal to Kw divided by Kb. We can alternatively use directly the value of pKa, and the pKa would be equal to 14 minus the value for pKb. Regardless of the method that you employ, I'm going to go for the second one. We're going to find that the value for pKa is going to be equal to 10.87. So, starting with our Henderson-Hasselbalch equation, pH is going to be equal to pKa plus the logarithm of the concentration of the conjugate base. In this case, I'm going to label this as B minus, as B directly. This is going to be our base. And the weak acid, we're going to label it as Hb plus, since it would be the trimethyl ammonium ion that would be generated. CH33 NH plus. This is going to be the actual weak acid that we're going to have in solution. Concentration of Hb plus. Okay. So now the desired pH is 11.02. The pKa is going to be 10.87. And this would be equal to the logarithm of the concentration of B divided by the concentration of Hb plus. In this case, we can do a trick that in order to simplify our calculations. Remember that the ratio of concentrations would be equal to the ratio of the amounts of mole that we're going to have in solution, since both of them are going to have the same total volume. Hb plus Mb divided by N of Hb plus. And doing the calculation of how much amount of mole of the weak acid that we need to add is going to be easier than to go through the concentrations. So in this case, in order to do so, we need to calculate the amount of mole of B that we're going to have of the base, which is going to be equal to the volume in liters of the solution, 0.450 liters, since we had 450 milliliters, multiplied by the molarity, 1.30 mole per liter. So the amount of mole of B would be equal to 0.585 mole. 5 mole. Let me correct over here, plus the logarithm of the amount of mole that we're going to get, 0.585, divided by the amount of mole of the weak acid that we need to add into our solution. So now, solving this equation, first of all, 11.02 minus 10.87 is going to give us 0.15, and this would be equal to the logarithm of 0.585 over the amount of mole of Hb plus that we need to add. We're going to take the base 10 in order to get rid of the logarithms. 10 to the 0.15 would be equal to 0.585 over amount of mole of Hb plus. With this, the amount of mole of Hb plus would be equal to 0.585 divided by 10 to the 0.15, which gives us 0.41415 mole. And now this, we need to convert it into grams. So we need the molecular weight for this compound. And this compound is going to have a molecular weight of 95.57 grams per mole. Remember that we need to round up our answer to two significant digits at the end. So the mass, now I'm going to write it down completely, of CH33 NHCl would be equal to the amount of mole, 41.415 mole, multiplied by the molecular weight, 95.57 grams per mole, which is going to give us 39.58 grams of the compound. And this value you can round it up as you desire. With that, it would be all. Thank you very much and have a good one.